today we're going to be finding the remaining zeros. Okay, you guys know what a zero is, right? We're going to be using something called the factor theorem to help us find the remaining zeros. Now, the good news is that you're going to use synthetic division to help you do this. So remember the box where we have the coefficients and you add and multiply and all that, okay? We are going to have to do some factoring, okay? We'll get to that, but let's start here. If you saw this in the last, 2 or 3 sets of notes, and the direction said factor, what would you have done? If I gave this to you and the direction said factor, how would you factor it? Caitlin? Yeah, like grouping. I agree, the first two and the last two. Or you can draw that and group them. Then you would find a greatest common factor. In the first set of parentheses, that's an x squared. And here's what I've got left, 3x minus 4. The greatest common factor in the second set of parentheses is a negative 4. But here's what I have left. At that point, what should you see? That's not happening. What do you notice? Olivia?
What's in parentheses isn't the same.
Yeah, it should match. That binomial should be the same. Okay? So, what we're going to be doing today is finding the factors using synthetic division, okay, because the factoring isn't working. Are you with me? Yeah? So, your directions are going to be very similar. It's going to say, factor this polynomial completely, but I have to give you one of the factors. I have to give you one of the binomials. You can't do it unless I give you one of those. Are you with me? Now, what does the factor theorem say? So you're going to have a polynomial. I'm going to give you a factor, x minus a number, x plus a number, whatever it is. You're going to use synthetic division. And what this means is that your remainder is going to be 0. Okay? If you divide 2 polynomials and the remainder is not 0, then the divisor, what you are dividing by, is not a factor of that original expression. We used factoring to try to help us find that. But when factoring doesn't work, we're going to use the factor theorem, which still helps us find the factors. It's just a different way of doing it. Are you with me? Okay, so there's going to be 3 options. And on your homework, there's 3 types of problems. Here's the first one, where we're using the factor theorem, where I give you a factor of the polynomial and you find the other factors. Okay? So here's your directions. I'm going to give you the polynomial. I'm going to give you one of the factors, and you're going to factor it completely. Here's your first example. Here's the polynomial. F of x equals 3x to the third minus 4x squared minus 28x minus 16. And the factor that I'm giving you is x plus 2. So here's the polynomial, f of x. Here's the factor of f of x. I guess I shouldn't draw that from f of x. That's the factor. This is one of the factors. Okay? You have to be given this in order to use the factor theorem, in order to do synthetic division. We got to factor this completely. So do you remember synthetic division with the half of a rectangle? Draw that for yourself. What number goes out here? Yeah, Gabby?
2.
Yeah. So, Gabby, when I gave it to you as a binomial, that's when we were doing division. What did I warn you about when I give you a binomial? If you see it as x plus 2.
Add plus.
Yeah, okay, yes. Use the opposite sign. Yeah. And how do we get that opposite sign, Gabby? If you were to set this equal to 0, you would you would subtract the 2 to the other side. So the x value of it, the 0, is negative 2. And that's what I want you to use. What goes in my box right here? Caitlin.
3 minus 4 minus 28 minus 60.
Yep, we call those girls the coefficients of your polynomial. So use the factor to find the 0. That's what goes out here. Write all of your coefficients in the top row. Now, if you need to like separate it, like draw your lines to keep your work organized, do that. How do we start synthetic division? Annabelle?
Bring the first number down and then multiply it by like the thing out front.
Negative 2, yeah. Which is negative 2?
Well, negative 6 and then put that in the 4.
Mm-hmm. So you always start with bringing down your leading coefficient. Anything that goes below my line gets multiplied by negative 2, by your 0. So negative 4 minus 6 gets me a negative 10. Multiply it by negative 2. You're adding vertically. Negative 28 plus 20 is a negative 8. What is that 0 called? Starts with an R. Yeah, Jana. The remainder. Girls, if you get anything other than 0 for your remainder, you did it incorrectly. Now, that's not to say what you were doing way back when we were dividing. You're allowed to get a remainder then, but you're not here. Okay? When you're factoring using the factor theorem, you have to get a remainder of 0. So I'm not done. What did I do with that? Chelsea, do you remember what we did with that? What did I do with the 3, the negative 10, and the negative 8? Okay, kind of, yes. How did I know what exponent to start with? Do you remember? So I gave you x cubed. Do you remember what my hint was? We're going to use... Annabelle?
Like 1 less than the grace.
1 less than. So you're gonna write a polynomial out of this. It's kind of gonna look like this, but Chelsea, I want you to use 1 less than 3. Okay? So these are your coefficients. You have 3x squared minus 10x minus 8. So remember what our directions say, girls. Factor completely. You need to see if you can factor that any further. How would you do that? Is there a greatest common factor? No. Your A value is not 1. So unfortunately, we have to do, Annabelle. That's when it's set equal to 0. I'm just factoring. It's not set equal to 0, right? So you could do guess and check. You could also do the A times C method. So A times C gets you negative 24. What are your factors of negative 24 that add to get you a negative 10? What multiplies to get you negative 24 but adds to get you a negative 10? Think about it. Savannah?
Negative 12 and 2.
Yes. I agree with 6 and 4, but they both would need to be negative, which would make this a positive, right? Yeah. So that if you added them both negative, it would get you negative 10, but not the correct sign of the 24. So remember, girls, from here we expand it. My goodness. Sorry. So I've got 3x squared minus 12x plus 2x minus 8. You group the first two and the last two. You find a greatest common factor. Okay, so I just took what I got from synthetic division and factored. Do we feel okay about that? Yeah? All right, so is that my final answer? How many x's do you see down there? If I were to FOIL, what would your highest exponent be?
Squared.
X squared? But Gabby, what do I want it to be? So what you need to do when we're factoring completely, I gave you one of those factors, right? The x plus 2. That needs to be included in your final answer, just straight up as you see it, the binomial. So I want you to add the x plus 2 to your answer, and that right there is your final answer. Now, this was the same problem that we started with, where you were trying to do it by grouping and it wasn't working. So that's why this is another way of factoring when you can't do those other methods. Are you with me? Yes? Okay. That's option 1. When your directions say factor completely, you should have factors as your final answer. So this is what it should look like. X plus a number, X minus a number, and depending on what you're, like, how many you get, you could have 2, you could have 3, you could have 4, whatever. You could have a greatest common factor. Annabelle?
I'm sorry. Could you repeat how you got the x plus 6 at the end?
I don't think I got X plus 6 at the end.
I meant x plus 2.
Yeah, so the directions said factor, where I gave you one of the factors, right?
Oh, yeah.
So we couldn't do this by grouping, but I'm telling you this is a factor. So you use synthetic division, make sure we do a remainder of 2. We took that polynomial and we factored by grouping, and we got this.
Yeah.
But if I were to FOIL that, I wouldn't get back to this, because this is a missing factor
Okay.
in your final answer.
Okay.
So if you were to FOIL and then do the rectangle method, then you would get back to this. But you can't forget to bring down that factor and put it in your final answer.
Okay, that makes sense.
Yeah. And I'm done, because I want my answers to look like factors. The directions are going to change and your answers are going to look different for the next 2 options. Okay? So here's option 2, where you're given one of the solutions. In this case, it's given in the table form, and you need to find the other solutions. So girls, your answer is going to look like this. X equals a number. How many solutions to this polynomial will there be? 3, because your highest exponent is 3. Okay? All right, so here I've given you a table of values for this polynomial. Like, these are your input values and these are what you get out. Okay? I want you to solve this equation when y equals 0, when your output is 0. You were doing this using factoring, but I'm going to tell you, factoring's not going to work. So, what I want you to do is I want you to look at this table. These are ordered pairs, right? X, Y. Where should I be looking in this table if I'm telling you the output is 0? Where should you be looking in this table if I'm telling you your output is 0? Which one of these has an output of 0? Annabelle?
Like
The 8, 0.
Yeah.
Right? That is where my output is 0. So that is where I want you looking. When you're solving, like this, that's always where you're going to be looking, where your output is 0. I have to give that to you or else it's not going to work. Okay? What do you call an ordered pair that's written as a number, comma, 0? What do you call an ordered pair that's written as a number, comma, 0? Yeah? X-intercept. Exactly. Good job. What's this? The y-intercept. Good job. Now, looking at this equation, you knew what the y-intercept was, right? Because this is in standard form, and you want to look at the constant in standard form. Okay? Now, this is in a table. The next example is where I give you the graph, but guess what? You can look at the graph and find your x-intercepts too. Are you with me? Yeah? So we'll do that one in a second. Here's what I want you to do. I want you to do synthetic division with this x-intercept. That x-intercept is going to be written as 8, 0, right? So the x value there is x equals 8. When I give it to you like this, girls, don't change the sign. Straight up use what I gave you. You only change the sign when it's written as like x plus 8 or x minus 8 as a binomial. Understand? Yeah, okay. So let's do synthetic division. Oh my goodness gracious. Let's do synthetic division with that as my 0 and that polynomial that I gave you. So just put all your coefficients in there. Okay, so 8 is my 0. Put your coefficients along the top. Do synthetic division the exact same way you just did it. Hopefully you get a remainder of 0. Make sure you do. Now remember, I told you your answers are going to look like x equals a number. You already know one of those numbers right there. But you have 2 more because you told me that there was going to be 3. So what do I do with that? The 1, the 2, and the negative 24. Annabelle? Write it as a polynomial. Good job. What would that be?
X squared plus 2x plus minus 24.
Good. And girls, I'm going to set it equal to 0 because your answers need to look like x equals a number. So you got to solve. That's what the directions say. Find the other solutions. Olivia?
So why did we get rid of the radical 3 and the other x?
The radical 3.
It was, not radical 3, to the third.
Oh, so you use this polynomial, you use the degree, and then you want 1 less than that when you write that after synthetic division.
Okay, so 1 less for all of them?
1 less than whatever you're dividing. Yeah. So this polynomial came from x to the third, right?
Mm-hmm.
Yeah, so guess what? On the next one, we're going to have to do synthetic division twice. So I'm going to use this, and then when I write that polynomial, it would be 1 less than this. Okay? So always look at what the degree is that I gave you, and use 1 less than it when you write your polynomial with synthetic division. Okay, 1 less than 3 is 2. Can you factor that?
No.
Yes, you can. What are your factors of negative 24 that add to get you 2? What are your factors of negative 24 that add to get you to?
-4.
Yeah.
I thought you meant a greatest common factor.
No, there's no greatest common factor.
Yeah, sorry.
That's okay. So you can say, well, x is going to equal negative 6. X is also going to be 4, but how many answers should I have? How many do I have right there? So what is my other answer? There you go. Be sure that you bring this 0 where your output is 0, right? Bring it down and make it part of your final answer. Do you see why this answer looks different than the first one? When your directions say factor, that's where you stop. The factors, the binomials, okay? When your directions say solve, that's what your answer looks like. Annabelle?
If it did say factor and we had to run there, would we make it x minus 8?
Yes, 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 exactly.
Thank you.
All right. Now, this is option 3, where I give you 1 0 and you find the other zeros. It's literally just a different way of asking it. Okay, a 0 and a solution, what we did up here, they're the same thing. So my answer for this one is also going to be x equals a number. How many answers should I have for this one? 4. If there are 4 zeros, how many x-intercepts might you assume there are? 4. However, how many, and that's what you see, right? 1, 2, 3, 4. They all pass through, so they all have an odd multiplicity. So all of their multiplicities are going to be 1. Can you identify any of these x-intercepts right now? Caitlin? Good. Is there any more that you can, definitely say? Okay, good. These other 2, you can see where they're at, but I don't want you to assume that's 1.5 or negative 1.5, okay? So guess what? You already have 2. You need to find the other 2 using synthetic division, okay? So this is just a different way that I'm going to give it to you. You're going to use negative 3 and 1 to do synthetic division. I don't care which one you do first. I'm just going to choose to use negative 3 first. All right, so do your synthetic division. I'm going to choose to use the negative 3, which was one of my x-intercepts. And I'm going to write all the coefficients. And do your synthetic division. Hopefully you'll get a remainder of 0. Do we feel okay about that? All right, now what do I do? So I want you to take that. Annabelle, what were you going to say?
Never mind. I don't think
I want you to take that and I want you to make a polynomial out of it. Olivia, what's the degree that I should use when I write this polynomial from those numbers?
X to the 3rd.
Right, because this was x to the 4th, so you want one less than that. These are your coefficients. So you're going to have 1 x cubed, and then you go down in decreasing order. Your remainder is 0, so you don't have to write plus 0 at the end. Now we can do this one of two ways. If you are able to factor this, you could factor this, just like we did in the last example, where we were able to factor it. But in the next example, I'm going to tell you, you can't factor it once you get to this point. So I'll show you how to do both. We'll factor it, and then I'll show you what you can do if you can't factor it. This has 4 terms, so we should use grouping. So group your first 2 together and your last 2. And find your greatest common factor. Now, we also want this set equal to 0, so just be careful. Don't forget that your answers need to look like x equals a number. This one, you were able to factor it. Can you factor this one any further? The x squared minus 2? No, because 2 is not a perfect square. So how might I solve that? I want to set each of those factors equal to 0. The second one's easy. X equals 1. There's an answer. How would I solve this first one? X squared minus 2 equals 0. Annabelle?
Take the 2 over and then take the square root of it, and it would be plus or minus radical 2.
Okay, there you go. So what's your answer? You've actually got 4 of them. You told me that at the beginning. X equals plus or minus radical 2. X equals 1. And then we also, which we knew 1. We knew 1 because it was part of our graph. You just also found that by factoring. And then also the x equals a negative 3. Now, you could see where the other x-intercepts were. They were right here and right here, right? But I said don't assume that that's like 1.5 and negative 1.5. Can you put radical 2 in your calculator? Everybody type it in. What's the square root of 2? Olivia, what'd you get?
1.4.
Oh, okay, so does that look about 1.4? Yeah? I have the positive and I have the negative. So Olivia, does that look about negative 1.4? Yeah, it does. So your answer should make sense with what you see on your graph. You just couldn't assume that. Somebody in my last class says, well, why couldn't I just type that equation that I gave you into your grapher and then find those? I don't know if there's going to be a no calculator portion of the test. I have to get there and look at that. But I also may ask for it in simplest radical form. In your calculator, when you look for the x-intercepts, is not going to give you that in simplest radical form. Okay, so factoring is going to work. It's going to have to be the way you do that. Now, if you could not factor what I have highlighted in yellow and blue, you could do synthetic division again. And I want to show you what that would look like. So if you did synthetic division again, let me move this down so it doesn't get too confusing. You would take all of these numbers from our first round of synthetic division and use them as your coefficients. So I'm going to use 1, I'm going to use -1, -2, and a +2. We already used -3, which was one of my x-intercepts. So what's the next one that I want you to use? You already know it. 1.
Could we do it in the opposite order?
You could do 1 first. And then you could do -3. Sure.
Okay.
Okay, so here, let's finish this. Wait, I think I did that wrong. Sorry. 0 times 1 is 0. My remainder is 0. But what do you get? Now, Olivia, I'm coming back to you. Write the polynomial from this. What degree do I use if these numbers came from x cubed?
Second.
There you go. So this, at this point, I get x squared. You can write plus 0x, but you don't need to. And then you would do it the same way. And you get that answer. Now, you just can't forget that you also had -3, 1, and then these two as your answers. You have 4. Are you with me? This x squared came because this polynomial right here that I did synthetic division on the second time had x cubed. Are you with me? Yeah? Okay. How much time do we have left?
I think 10 minutes.
10 minutes. Here's what I want you to do. I want you by yourself to start on this one. I'm going to spoil it for you. You're going to have to do synthetic division twice. Okay? This is x to the 4th. So how many x-intercepts would you anticipate there would be? 4, but how many do you see? 2. However, hold on, listen. Don't work on this yet. Just listen to me. Is this an even or an odd multiplicity?
Even?
No, it goes through, so it's odd. What's that multiplicity? Odd. 2 odd numbers are not going to add to get me 4, right? So those each have to have a multiplicity of 1 and 1. That's only 2. What about the other 2 zeros? You don't see them on your graph, so what kind of numbers are they? They're what? Imaginary. Good job, Chelsea. They're not going to be x-intercepts, but they're still going to be zeros. You're still going to have 4 zeros, but you're only having 2 x-intercepts. Are you with me? Okay, try it. Just get started on it. See what you can do. Synthetic division with -3 and 4. Yeah.
Can you go back?
Yes. To which part? Just right there?
The second.
This right here? The second synthetic division?
Can I get your back?
Sure. Okay, can you work on this? Thank you. Yes, because it's -3 there. When it's written as an ordered pair, you can use the same sign. Yeah. So that's just gonna change all your signs, basically. You can't, if you try to do grouping, it's not gonna work, right? So like the last one, we could factor by grouping. This one's not, so you're gonna have to do synthetic division again. These same coefficients, but then you use your other 0, which is a 4. Does that make sense? So remember, girls, on your second round of synthetic division, use those numbers that you got from use those coefficients that you got from the first round with your other 0, the other x-intercept. You should use one and then the other. Yeah, just stop there. We'll come back there. You can't factor this by grouping. Do you see how they don't work? That's why you have to do synthetic division again with all of these numbers.
So like this one?
Yes, exactly. And your other x-intercept, which is 4. Yeah, that's not going to work. Do you see how these don't match up? So that's why I said you have to do synthetic division again. And you're going to use these numbers with your other 0, which is 4. Does that make sense? Good job. Do synthetic division again with these coefficients and your other x-intercept. Yeah? Yes. Add vertically. Yeah, so you got it right here. What's -5 times -3? Then you keep adding, and you put a number below it. Does that make sense? You just keep doing the same thing.
So I just get stuck when I get to that part.
Yeah. So that's me. I remember I told you. You would see if you could factor it, like we did up here. But if you can't, then you have to do it again, synthetic division again. So I want you to take all of these numbers, and those are going to be the coefficients here, but you're going to use your other x-intercept and do it again. And once you do synthetic division again, I want you to stop because I'm going to come back. Yes, good, you stopped there. Okay, good. Now, unfortunately, we can't solve that by taking the square root because there's an x. You could do that if there wasn't just an x. So stop there, and we'll talk about it. Good job, stop there, we'll talk about it. I think that this is
23?
This is a -10.
I wrote 1. Why did I write 1? I wrote 1 to less. I'm so confused.
-9 plus 15. What'd you get? Okay, do it again with x equals 4. Because that, Giselle, the last one, we factored it. But that, if you try grouping, it won't match up. It won't be able to, you can't factor it. So that's when you can do synthetic division again. Do it again. Except you forgot to bring down your 1x. You forgot to bring down your 1. So that's your leading coefficient. Right? So, right. There you go. There you go. Perfect. Do it again. With this. No. These. Yes, exactly. Those numbers that you got. Yeah, good job. So you're going to have to do that.
Can I see what you
Because you can't find your factors of 2 that have -1.
Oh, okay, perfect.
All right, girls, great job. Okay, now, if you try to factor that, which really is what we did on the last one, you're not going to get things that match up in your binomials. So that's why I said if you can't factor it like we could up here, then you have to do synthetic division again. Okay, so here's what I want you to do. I want you to take those numbers, come on, and do it again. Do you see that? I took all these numbers and I did it again with my other x-intercept. Okay? All right, so if you didn't get this far, just take a look at what I have.